Hello class, welcome to section 5.4 in Algebra 1. We are on page 139. Page 139. Alright, we are continuing with our solution sets of linear equations, and as we've done so far, we have solved it three different ways. One, we've used graphing. Two, we've used substitution. And three, we've used elimination. And today, we're going to be using all three. Okay? I'm using all three for today's class. Now, when you solve a system of linear equations, there are three possible outcomes. One outcome is the lines cross and you get one solution. Another outcome is you have two parallel lines and you have no solution. Those lines will never cross, so there will never be a point where those two lines cross. And then this third is if you have two lines, you can't see it here, but there are actually two different linear equations under here, and the lines are exactly the same, which means you have an infinite number of solutions. So the lines are the same, you have an infinite number of solutions. The lines are parallel, you have no solutions, no place where they cross, and you have two separate lines that cross at one point, giving you one solution. So today we're going to be looking at lines, systems of linear equations, and we're going to be figuring out if there's one solution, and if there is, we're going to figure out what that solution is, what that point is. Or we're going to find out that they are parallel and that there are no solutions. Or we're going to find out that they are, in fact, the exact same line, and so they meet at every single point on the two lines, meaning there's an infinite number of solutions. So we're just going to get straight into it. If you'll turn with me to page 140, we're looking at number one here, and I will do the odds, and you will be expected to do the evens. So let's look at number one here. We have y equals 3x minus 7. And we have y equals 3x plus 4. Okay? So the first thing we're going to do is we're actually going to go into Desmos, and we're going to see if see what Desmos says. If there's one solution, no solution, or infinite number of solutions. So we'll look at Desmos. I've already put the equations in. So here's our two equations. Y equals 3x minus 7. There's that line. And then right here we have y equals 3x plus 4. There's that line. And look, well, it looks as though the lines are parallel. The lines are parallel. So what that means, if the lines are parallel, they will never cross. So in here for the notes, I will put no solution. So I'm expecting you, part of what you're handing is the URL from this Desmos calculator, where you're going to have every single slope, every single linear equation, plus the answer. So this is number one. There's my two lines. I see that those two lines are parallel. They have the exact same slope. If you look here, the slope is 3, and for this equation, the slope is 3. But the y-intercepts are different, so I have no solution. They will never meet. So when I go back here, I know by Desmos that there's no solution. Now what I'm going to do is I'm going to pick one more way to solve this. I'm going to pick one more way, either with graphing, substitution, or elimination. So with this one, I will show you both ways. I'm going to show you both substitution and elimination. You only have to pick one and do it, but I'm going to show you that you could solve it by both. So let's first do substitution. So if I use substitution, okay. If I use substitution, what I'm going to do is I'm going to substitute this in for this y, right? Because y equals this, so I have 3x plus 4 equals 3x minus 7. So I'm going to take the x's to this side. Those cancel out, I get 0. So I have 4 equals, those cancel out and get 0. 4 equals negative 7. Well, that's never true. So with arithmetic, I also get no solutions. So Desmos, I got no solutions with graphing. With substitution, I get no solutions. And now the last one I'm going to do is elimination. And again, you only have to do one of these two, substitution or elimination, plus the graph. So you have to do the graph plus 1. So elimination, I have y equals 3x minus 7 and y equals 3x plus 4. Well, this is lining up perfectly. So what I'm going to do is I'm just going to add the opposite. So y equals, well, I'm going to subtract. So I'm going to subtract this whole thing. So I'm going to subtract this whole thing, which means I have to distribute the negative through the whole thing. So I'm going to keep this one, y equals 3x plus 7, minus 7, excuse me. And then I'm adding the opposite. So this is a negative y, this is a negative 3x, and this is a negative 4. So I get 0 equals 0 minus 11. 0 equals negative 11. That is never true. So again, no solutions. Now it's no surprise that I got no solutions because I already got no solutions 2 other times. But I'm just showing you how you can solve with substitution and you can solve with elimination. So substitution and elimination. Again, you have to do one of these two plus the Desmos graph. Alright, now we're going to move into, let's check out number 3. So here we have number 3. We have 2x minus 3y equals 10. Negative 2x plus 3y equals negative 10. So, first step, let's plug these into Desmos and see what Desmos says. Alright, 2x, I'm going to take those two out. 2x minus 3y equals 10. There's our first equation for number 3. Our second equation for number 3 is negative 2x plus 3y equals negative 10. Oh, look at that. There's our purple line right there. And then our black line is right on top of it. So not only are they parallel, they are exactly the same line. Exactly the same line. So what that means is that we have infinite solutions. That means that every single point on this line is a solution for the other line. So that's how in Desmos we solved it as infinite solutions. So let's look at arithmetic. And what I'm going to do, I'm just going to subtract these. So I'm just going to add these, excuse me. I'm going to add them. 2x minus 2x is 0. Negative 3x plus 3x is 0. 10 minus 10 is 0. 0 equals 0. That means I have infinite solutions. Infinite solutions. So I used this one. I used elimination. So if you're able to pick the one that fits best, it can be as simple as this. So your work for number 3 needs to include the Desmos calculator that shows infinite solutions, and you need to have either elimination or substitution, whichever one you choose. I did elimination for this one. All right, moving on to number 5. Number 5 is 6x plus 6y equals negative 3. Negative 6x minus 6y equals 3. So there's our solution. There's our 2 lines. Those are our 2 lines. So first step is I'm going to head over to Desmos calculator. And I'm going to take our last 2 lines out, and I'm going to go to number 5, which is 6x plus 6y equals negative 3. Negative 6x minus 6y equals 3. Oh, let's get the lines up there. 6x plus 6y equals negative 3. 6x, negative 6x minus 6y equals 3. Well, it looks like we have another set of parallel lines. What does parallel lines mean? It means I have infinite solutions. Boring, just did that, but that's okay. So, how do I solve this arithmetic? Using arithmetic? Well, I have a positive 6x and negative 6x. Let's just add them. Positive 6x, negative 6x is 0. Positive 6y, negative 6y is 0. 0, oh great. 0 equals 0. Infinite. Ooh, that's an ugly infinite. Infinite solutions. Again. Okay. Boring. Again, you can solve it with substitution or elimination. I chose elimination. I chose elimination, and it worked out just fine. Confirmed Desmos. Alright, you know what? Maybe if I change pencils, we'll get a better one. Let's look at number 7. Number 7, we have 2x plus 3y equals 1. Negative 2x plus 3y equals negative 7. Alright, first place we're going to go to is Desmos calculator. Let's check out those two lines, see what we get. Take those out of there. We have 2x plus 3y equals 1. And then we have negative 2x plus 3y equals negative 7. Oh, look at that. We got one solution. And that solution is 2, negative 1. So we have one solution. Woo! 2, negative 1. Yes! Alright, so now we finally get a fun one that we can solve with substitution or elimination. Now I see right here that these two will cancel out if I just add them. So I'm going to do elimination. So I get 0 plus 6y equals negative 6. Divide by 6, divide by 6, I get y equals negative 1. Hey, that's what I just got on Desmos. Nice. So I'm going to plug this y in. I think I'm going to plug it into this one. So 2x plus 3y, because I still need my x value, right? So 2x plus 3 times negative 1 equals 1. 2x minus 3 equals 1. Plus 3 plus 3. 2x equals 4. Divide by 2. I get x equals 2. So there's my solution. 2, negative 1. That's confirmed by Desmos, and so I'm good. So here I solved by elimination, and boom, I got the same answer as Desmos. Don't forget, you only have to use one substitution or elimination to solve it. All right, let's move on to number 9. Here we have number 9. 3x minus 2y equals 6. Negative 9x plus 6y equals negative 18. Alright, these are getting better. They're looking more fun. Okay, so let's plug these into Desmos, see what we get. Take those out, and we'll go down to our new one. 3x minus 2y equals 6. Is there? And then we have negative 9x plus 6y equals negative 8. Negative 9x plus 6y equals negative 18. I wonder where I got that 34 from. Oh, great. So, they're just parallel lines. What does that mean? Parallel lines, what does it mean? No solution. Boring. Okay, so, here we go. So let's solve it with some. I'm going to do elimination again, and what I'm going to do is I'm going to multiply this one by 3, and that's going to get us to a positive 9. So we'll multiply this one by 3. Don't forget, you have to multiply everything in here by 3. So I get 9x minus 6y equals 18. Negative 9x plus 6y equals 18, negative 18. Add the 2, 0. Plus 0 equals 0. 0 equals 0. So I have infinite solutions. Oh, wait. What? This says infinite, but my last one I have parallel. what just happened? 3x minus 2y equals 6. Negative 9x plus 6y equals, oh, that's supposed to be a negative 18. Oh, there we go. My Desmos was wrong. Hopefully you guys are still watching this video. I didn't put a negative 18 in here, so it looks like those lines are right on top of each other. They are the same line, so we have infinite solutions. Okay, that was good. My math was better than my Desmos calculator. So there it is. Infinite number of solutions for number 9. Alright, and let's do number 11. I have 3x minus 8y equals 3. 8x minus 3y equals 8. So, let's check this out on our Desmos. 3x minus 8y. 3x minus 8y equals 3. 8x minus 3y equals 8. Oh, look at that. We got one solution. 1, 0. So we got one solution, and that is 1, 0. Yes. All right, another fun one, finally. These are few and far between. So let's do the arithmetic for this one, and what I will do for this one is I think I'm going to solve by substitution, because I haven't done a substitution yet. So I'm going to take this one, 8x minus 3y equals 8, and I am going to solve for x. So plus 3y plus 3y, 8x equals 3y plus 8, divide by 8. Ooh, hey, that's going to give me a yucky fraction. X equals 3/8 y plus 1. So I'm going to plug that back into here. So I have 3 times 3/8 y plus 1 minus 8y equals 3. So I have 9/8 y plus 1 minus 8y equals 3. Whoa, yuck. Oh my goodness. Oh gosh. Minus 1, minus 1. I get 9/8 y minus 8y equals 2. So, let's turn this. So 8 times 8 is 64. So we're going to go 9/8 y. Ooh, that doesn't work. What do I do? Oh, this is a 3. This is a 3. So minus 3. Minus 3, so that's 0. So then, whatever I get here, so I get minus 64, 64ths y. So 9 minus 64, so that's negative 55, 64ths y equals 0. Multiply this by 64 55ths, 64 55ths. I get y equals 0. Whoop, 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 whoop. Because 0 times anything is 0. So now I'm going to plug that back in. Let's plug it into this one. So I have 3x minus 8 times 0 equals 3. 3x equals 3. Divide by 3, divide by 3. X equals 1. And so I have 1, 0. There it is. Just like on Desmos. All right. Do the homework. Make sure you solve it in Desmos. Share the URL with me. And all is good. All right.